calculate,
Yes.
Calculate the geometric mean, harmonic mean, and quadratic mean of the set of numbers 2, 4, 8. So the solution goes thus. Okay. So geometric mean. Geometric mean is equal to the product of the variables, let's say x1 times x2 times, and so on to Sn. This is the n roots. What that one means is that the three variables were given. We're given 2, 4, 8. We'll multiply these three numbers together. And because they are 3, it becomes the n roots. Assuming the numbers were 4, for instance, 1, 2, 4, 8. I'll multiply all, and n will now be 4. So in this case, we have only 3 numbers is there. N cube roots of 2 is 4 times 8. And that will become cube roots of 8 times 8 is 64. The cube root of 64 should be 4. 4 times 4 times 4. And that is the answer to that question. Is it clear?
Yes.
So that's how to find harmonic geometric mean. And that is the result to that question. The next thing is harmonic. Please put that one down if you have not.
Okay, you can play.
Okay. You are done?
Yes.
Okay. The next thing is harmonic. Harmonic has a formula, and that formula is very clear. In this case, we'll have something like this, a formula like this, harmonic mean. That one is equal to n over summation of 1 over x. That's our formula. And there is the number of the whole thing we are talking about, where it's 3 here. So that place will be 3 whole number. And each of the numbers is 2, 4, 8. So we take inverse. 1 over x, the variable is 2. So 1 over x. But assuming there is a frequency, that place you saw 1 will now be f over the result. For instance, this is 3 as n, all over 1 over 2 plus 1 over 4 plus 1 over 8. So that's the meaning of sum of the inverse of the variables. Each of the variables you take inverse. Assuming there is a frequency, so that we don't bother accept too much. Assuming these numbers you are seeing was like this. Let's assume we had something like this, that this one is x, 2, 3, okay, 4. And this one is 8. This frequency, maybe I have 1, I have maybe 3, maybe 3. Maybe here is going to be like a 2. Assuming this is a table, which means a variable and frequency. If I want to find harmonic mean of this, my 1 will turn to f. There will be summation of f over x. So here will now be 1 over 2 because our frequency is 1 and denominator is going to be 2. This my 1 here will now be 3 over 4 because the frequency for 4 is 3. This 2 will be 2 on top and 8 will be there. So this my formula will change to this one whole number you're saying will now turn to f as in frequency. Did you understand?
Sorry, can you come again?
Okay, but this one, do you understand this one on the board?
Yes, I understand the one on the right. You said the denominator will be the numerator.
Assuming this table you are seeing on the corner is the frequency distribution. X is 248. Frequency is 132. Our formula will change. H will be n over summation of f over x. Are you there?
Yes.
So that means this place is sub-frequency. Instead of me writing 1 over 2, what happens that frequency here is 1. So it will be 1 over 2 plus 3 over 4 plus 2 over 8. Is it clear?
Yeah.
Good. That is, it is frequency distribution that has frequency. But this one is a single set of number 2, 4, 8. So that means that I'm going to add the denominator 1 over 2 plus 1 over 4 plus 1 over 8. All the results for denominator, your calculator can do that for you. Half plus 1 over 4 plus 1 over 8. It will give you a fraction. What do you have?
Sorry, 1 second. 1 over 2.
Okay.
I'll put it in brackets. Well,
No, you don't need bracket. Just your calculator can run straight. 1 over 2 plus 1 over 4 plus
okay.
1 over 8. Press equals
0.875.
So is it giving you decimal?
Yes.
875.
Yes.
I mean denominator. Is it possible? 1 over 2 plus 1 over 4 plus 1 over 8. Will they give you 8 points? What do you call it? Is it possible?
Yeah, 0.875.
Good. So let's find it. 1 over 2 plus 1 over 4 plus 1 over 8. I don't think, but let me just do something here. LCM, if you look at that denominator, it's fraction. 1 over 2 plus 1 over 4 plus LCM is 8. 2 in 8 is 4. 4 times 1 is 4 plus 4 in 8 is 2. 2 times 1 is 2 plus 1. We're having 7 over 8. So 7 over 8 cannot give you 0 point something. It should be, it cannot give you 8 point something. It should be 0 point something. Abi?
Yeah, now 0.875.
Is that what you say you got?
Yes.
Okay. If that is the case, so that means our denominator will become 3 over 0 point. So divide it now. 3 over that result. 3 whole number for numerator over that result 0 point something. So what's your final answer?
3.43.
Good. You are correct. So harmonic mean is equal to 3.43. So that's how to find harmonic mean of a set of numbers and the formula I gave to you for frequency distribution. Is it clear now?
Yes.
Finally, geometry. So the quadratic mean. You know, the word quadratic, I don't know whether you were taught that, but that's not a problem. Quadratic mean, from that word quadratic, quadratic has power 2. Hello?
Yes, I'm with you.
Quadratic means the highest power is 2 whole number. So this one will be summation of all the squares of the variables all over the total number. Summation of all the square of the variable all over the total number. Is that okay? So
Yes.
we can also use the same number, it doesn't matter. Let's use the same thing. So in this case, quadratic. Quadratic. Quadratic mean is equal to the square root, because it's quadratic, it must be square root, all over summation of x squared, all over n. Remember, it covers all the square, summation of the x squared. That means each of the variables will be squared and added to them, all over the total number. The total number here is just 3, and that's what this question is all about. So automatically, we are looking at a situation whereby we'll have 2 squared plus 4 squared plus 8 squared. It's just to remember the formula, that's all. Okay, to remember the formula, the problem becomes so easy. How many number there? 3. I will look for the square. That means we are to find out 2 squared is 4 plus 4 squared plus 3, 8 squared. Even your calculator can do it. You can just type 2 squared plus 4 squared plus 8 squared divided by 3. You get the value. That means this is 4 plus 16, that should be 20. 20 plus 64, that should be 84, divided by 3. I will find this one. Can you cross check?
Yeah, 84 divided by 3.
By 3, yes. 28. What do you have?
28.
Exactly.
So square root of 28 is 5.29.
5.29. So that is it. So that's how to find this other type of means. We know we have found arithmetic mean, we have found harmonic mean, we have found geometric mean, we have found quadratic mean. That is our. So we are moving into group data. Still a measure of position. Under the measure of position, we looked at mean, mode, median. The mean, we looked at different types: arithmetic mean, harmonic mean, geometric, and quadratic. So we're moving now to group data. Are we set?
Yes.
Good. Group data of measure of position. Group data. It is group data. It is a data that has been organized. It is a data that has been organized into groups. Full stop. There are basically 2 types of groupings. Only 2 types. There are basically 2 types of groupings. Namely, A, up to.
Up to
Grouping, up to, UP, up to
okay.
Grouping. This is a type of grouping, up to grouping. This is a type of grouping. This is a type of grouping. The type of grouping that does not overlap, that does not overlap, or extend, that does not overlap or extend to the next group, Type of grouping that does not overlap or extend to the next group. Full stop. Example of this type of grouping, is depicted or shown below. Depicted or shown below. Here's an example of that kind of grouping. Is how it looks like. We'll have, let's see, this place. Are you there?
Yes.
That place, you help me write average hourly earnings. Average hourly earnings. That should be in naira or whatever. Or numbers, let me look at numbers. Average hourly earnings. The next one here, this one here, that one here. Number of workers. Are you there?
Yes.
The first one here is 5 to 9, 17. The next one is 10 to 19. Oh, sorry, 10 to 14. 10 to 14, you have 32. The next one is 15 to 19. 15 to 19, we have 25. The last one there, 20 to 24. 20 to 24, we have 24. You will agree with me that the first group started from 5 up to 9. Does it extend to the next group?
No.
No, that is up to grouping. And it is this type of grouping that is common in examination. 5 to 9, 10 to 14, 15 to 19, 20 to 24. And if we see this type of grouping, we'll try changing it from this type of grouping to the other type of grouping. For instance, this is up to grouping. We'll change it from up to grouping to less than grouping. That means what you are seeing on the board, 5 to 9, 10 to 14, is what we call class limits. The limit for the first group is 9. The limit for the second group is at 14. It doesn't pass that. So there will be what we call upper limit and lower limit. So the lower limit for the first group is 5. The upper limit is 9. Lower for second group is 10. Upper is 14, just like that. So when there is a class limit, there will be up to grouping. And from class limits, we'll convert it to class boundaries. Class boundaries, where we'll begin to have what we call less than grouping. But that's the first grouping. The second one is called less than grouping. Less than grouping. B, less than grouping. Just the opposite of that one. Less than grouping. It is a type of grouping. It is the type of grouping that overlaps or extends to the next group. It overlaps or extends to the next group. The data below shows an example of less than group. The data below shows an example of less than grouping. Just like we did the other time. The first one here is weights. Weights, which is in gram. This one is a number of coconuts. Number of coconuts, and this is 0 to 10. This is 10 to 20. This is 20 to 30. This is 30 to 40. This is 40. This is 40 to 50. This is 2. This is 6. This is 19. This is 27. As in and then finally, there is 10. If you look at this very well, the first group starts from 0. But it's less than Abby?
Yes.
Because the next group is starting from 10. And it's less than 20. Because the next group starts from 20 or less than 30. See regularly in exam, they don't send this type of exam. The boundaries, class boundaries, because everything is moving from one level to another. In this case, there will be lower class boundary and upper class boundary. We don't need to convert a distance to anything. It is that class limit we convert. If it's whole number, we subtract 0.5 from the lower and add 0.5 to the upper. But less than grouping, we don't, because there is nothing to subtract from this. So like I said, this type is not always. Is it clear?
Yes.
Good. So let's take a question, see how it works. When there's a group data and mode and all the rest. So let's see. That table I gave to you, the first one. Okay. Okay. Let's use this one. Let's use another one. Let's use this one. There's another one here, which is quite different. So that we can answer so many questions in it and be able to understand the meaning of boundaries and people. And use it to answer some questions you may need. Okay, let's see. Question 2 for today. The table shows the frequency distribution. The table shows the frequency distribution of the heights of 40 students in a class. Height of 40 students in a class. This place is height. This one is the number of students, which you know is frequency. Height is the first one in centimeters. Next one is a number of students. So the first group is 155 to 159. The next group is 160 to 164. The next group is 165 to 169. The next one is 170 to 174. The next one is 175. 175 to 179. The next group is 180 to 184. Our frequency here is 3. No, sorry, this is 5. Frequency there is 5. This one is 6. This one is a continuation of what we have from that side. Okay, now 170 to 174 is 8. This is 10. This is 6. This one. So I have 5, 6, 10, 8, 6, 5. Is it clear?
Yes.
So the question says, use the information to answer questions below. Use the information to answer questions below. Okay. Question A. What is the upper class limit of the second class? What is the upper class limit of the second class? Limit. Upper class limit of the second class. C. Determine the class boundaries of the fourth class. Determine the fourth class. Determine the class boundaries of the fourth class. So make it letter G. Letter G. Find the mean, mode, and median. Find the mean, mode, and median. Full stop.
Sorry, can you call the questions again? The ABCD. Is it 4 or be 3? I got 3.
Okay, let's say A. What is the upper class limit of the second class?
Okay.
B. What is the lower class limit of the second class?
Okay. All right. Got it.
Okay, good. So that means the first question. Can you answer the A?
Yes, 160. 160.
Are you sure? Is it what is the upper class limit of the second class? What is the second class actually?
The second class is 160 to 164.
So what is the upper class limit?
Okay, 164.
Better. That
Okay,
one is answer. So B, the lower class limit is what?
160.
Good. C is talking about the fourth class, which we are going to look at. C is talking about the fourth class. The fourth class is 170. So this is the fourth class. 1, 2, 3, 4. Fourth class. That has a frequency of 8. So
yes.
automatically, the lower class limit here is 170. The upper class limit is 174. We have to change it from class limit because what you are seeing here is class limit. This class limit. We have to change it from class limit to class boundary by subtracting 0.5. 0.5 means 0.5 because 170 and 174 are all whole numbers. Because they are whole numbers, subtract 1 decimal, 0.5. If they are decimal, you subtract 0.05, 2 decimal. But for now, when you take away 0.5 from 170, you are bound to get 169.5. Agreed?
Yes.
And because you have taken away 0.5 from 170. You'll also add it back. You add 0.5 to 174, and that will give us 174.5. This particular thing you are seeing now is what was bound. Boundaries between one state. So when you talk about boundaries, not that there are two lines, it's just one particular line that separates this state from the other state, or country from another country. One leg can be in a particular state, and like Ogun State now, one leg can be in Ogun State, while the other leg is in Lagos. So there's a line that separates the two states, which is called boundaries. A limit means there is a far point that you must not go beyond. So that is the answer to determination of class boundaries in this question. And from all indication, this one is lower class boundary, Abi? Lower class boundary. And this one is upper class boundary. So we must understand that, because you cannot find mode and median without the knowledge of class boundary. The formula for mode, the formula for median has to do with boundaries. It does not work with limits. Is it clear?
Yes.
So we're going to find median first, then we apply formula for median, and we'll get this. So what we do in this case is this. Those questions were written. We may try going this way. Okay. This way. We'll draw a line like this. Go this way. This is our x. Those heights are the x and frequency. I will have what we call midpoint or mid-class, whichever one. Sorry, this is our class, sorry. This is our class, because that's where the height is. That's the class. This is the midpoint that we'll call x. This is not the real variables. The class of the group is what you know already. So the first one would be 155. Do you help me write? 155. Oh, this one is not good. Let me make it lower. So this class is the frequency. There's midpoint or mid-class, which we call X, 55. 155 minus 159. And this is 5. The next one is 160. 164. The next one is 165 to 169. The next one is 170 to 174. The next one is 175 to 179. Finally, 180 minus 184. We have 10. We have 8 again. We have 6. We have 5. So what we do in this case, because this is class, there's a class of the height. So we have to get the midpoint. Either they call it midpoint or center point or mid-value, whichever grammar they want to use. All of the what we're after is we're looking for the center point between the upper limits and the lower limits. So help me add 155 plus 159. That is the lower plus the upper divided by 2. What do you have? The lower plus the upper divided by 2. Because I want to look for mean. The first thing I want to calculate is mean, the arithmetic mean, not harmonic mean, not geometry. So what? Arithmetic. Oh yeah. 155 plus 159 divided by 2.
That's 314 divided by 2. That's 157.
Yes. No, I mean 155 plus 159 divided by 2. 1.
Yes, 157.
Good. 157. Next, 160 plus 164 divided by 2.
162.
162. Now let me show you something now. If the intervals are equal, you don't need to be doing it till the end. If the intervals are equal, if you check. For instance, now 155 to 159. I hope the difference is 5, Abi. Say 5 or 4?
Yes, it's 5.
We added 4. Let's say 4. They added 4 to 155 to give us 159. They added 4 to 160 to give us 164. They added another 4. That means the interval is even. The intervals are equal. If that is the case, I don't need to stress myself. For instance, the first one gave me 157. Second one gave me 160. What's the difference? 3.
5.
No. Is it 5? No, I'm talking about the answer you got.
Which one?
You
No, it's
got
162, not 160.
Oh, 162.
Yes.
Okay. So the difference is 5, Abi?
Yes.
So the next one will be 167. The next one will be 172. Oh yeah, check so that you know what I'm talking about. 165 plus 169 divided by 2. What do you have?
$167.
So that means I don't need stress. This one will be 177. This one will be 182. Is it clear?
Yes.
So I will now do this again. You remember Fs? Our F now is the frequency. I hope they do complete this at 3, yes. The frequency is our F. So that class now, we will abandon it. The thing will not be as if we have one variable and a frequency. We now do our normal mean, F times X. I have multiplied 157 times 5.
157 times 5.
157
785.
times 5. 785. The next 162 times 6.
162 times 6. 972.
972. 167 times 10. That one is clear. 1670. Next 172 times 8.
1376.
1376. 177 times 6.
1062.
1062. And the last one, 182 times 5.
910.
910. So we'll now add all this. So try and add I know the frequency should be 40. I hope that one is clear because they have already told us it's 40. Even if we still calculate, it's still 40. 11 is 22 plus 8. That will be 30, 40. So frequency is very clear. It's 40. It's 40. So this side is what you add for me. 785 plus 972 1670 1376.
6775.
6775. 6775. So we have gotten the value. I hope you have taken note of that. 6775, and this is 40. So to get the mean will be summation of fs all over summation of f. Are you through with the board or copy?
Please just a second. Let me complete.
Okay, go, please.
All right, continue.
Okay. Now, finally, the mean for this question, the arithmetic mean, will be summation of fs all over summation of f, which is 6775 all over 40. So our mean, which is s bar, will be equal to
That is 169.4.
169.4. So it's very clear. That's how to find mean. First part of the question answer. The second part, which is median. Median for a group data has a formula. Mode for a group data has a formula. So we're going to apply the formula and then solve median and also solve mode. Can I clean?
Yes.
Good. So for median, which is a second part of the question, median is defined as L1 plus n over 2, capital N over 2, minus summation of FB. Any person can make his own formula different, but I don't know. But all I know is that the idea remains the same. Median, but the nomenclature is almost the same. But this is common. So the interpretation here is where L1, are you there? L1
Yes.
is low. L1 is lower class boundary. Lower class boundary. That's the meaning of L1. Lower class boundary.
Okay.
Capital N, from what we have known, our capital N is summation of F. I hope it's clear.
Without n, summation of f.
Summation of frequency. That's the meaning of that N. Capital N. If the total number is 30, that is 30, we'll write. If it's 40, we'll write 40. Unlike this one we are solving now, the total is 40. So it's going to be 40 over 2. The next one is summation of FP. The meaning, sum of all. Are you there?
Yes.
That's summation of FP. It means sum, which is addition. Sum of all frequencies, before, of all frequencies before the median frequency, before the median frequency. That means if the median frequency is like 10, the frequencies before 10 is what we're going to add together. That is the summation of frequencies before the median frequency. This FM, the FM is, we'll just turn it around. FM means median frequency. FM means median frequency. That means if the frequency of median is 10, that's what we're going to put there. Why the C you are seeing on the board is the length of the class interval. You know, from 155 to 159, the interval should be 5. So length of class interval is what we're talking about here. Length of class interval. So based on this formula now, from our question, we can answer this. If you look at the class, we have 5, 6, 10, 8, 6, 5. Like I told you the other day, you can use this formula n plus 1 over what? 2. This is a median position. It's not a formula. It's a formula to determine the position of the median. And how to do that? You look at this question, the total number is 40. 40 plus 1 will be 41. 41 divided by 2 should be 20 and a half, Abby. Are you still there?
Yes.
So that means 40 plus 1 is 20 and a half. And 20 and a half means the 20th number and the 21st number is the one that falls at the middle. And if you take time to start from beginning, 5 plus 6 is 11. 11 plus 10 is 21. That means 165 to 169 is the median group. Inside this 10, Abby?
Do
you agree?
Sorry, can you say that again?
I said n plus 1 over 2 TH. That is the median position. That n plus 1 over 2 means median position. The position where the median will fall, where the variable will fall at the middle. So I said,
yeah, so what's the FM? What's the FM?
FM is median frequency.
Yes, I'm saying what's the figure? Do we have the figure?
No, there's no figure there. Now we're looking at where it will fall. The median class is 165 to 169 because the median falls in that 10. The median frequency is 10. Do you agree?
How is it 10, please?
That's what I'm trying to explain. Look at the formula on the n plus 1 over 2. N is 40, Abby.
Yes.
40 plus 1 is 41. 41 over 2 is 21 and 20 and a half, Abby.
Yes.
So it shows that the variable that will fall at the middle should be the 20th and the 21st variable. And if we try adding from the left-hand side, 5 plus 6 is 11. 11 plus 20 is 21. That means the 21st and the 20th and 21st will fall under this 10. Are you sure you got it?
Okay, yes. 5 plus 6, 11 plus 10, 21.
10th and 21st will be then, Abby. Will
Yeah.
be in this 10.
Yeah, it should be
So
between
in
them.
this median, okay, our median frequency is 10. Our
Yes.
median class is 165
55 to 169.
That's
Yes,
set
okay.
to. If that is
Yes.
set to, that means the median class, that is 165 to 169. That's the median class limit. Take note. Median class limit is 165 to 169. And the median class boundaries is 164.5 to 169.5. Is it clear?
Yes.
Now we are using the second one. Our L1 is lower class boundary. So the lower class boundary is 164.5. Our N in that formula is 40. Remember, our median frequency is 10. The frequencies before 10 is 5 plus 6, which is 11, have you?
Yes.
And FM, median frequency is 10. So everything is sorted out. A class interval, if you subtract this, 169.5 minus 164.5 is 5. So that means the class length is just 5. So to answer this question, it will now be median. From that our formula, L1 is L1 is 164.1 plus N is 40 over 2. Summation of frequencies before 5 plus 6 is 11. Okay, all over 10. Times
5.
Good. So the next thing is just
20 minus 11.
so it's going to be 164 plus 5 plus 20 minus 11 all over 10 into 5. So we're having 164.5 plus 9 over 10 times 5. Remember, this will now be 4.5. So it's going to be 164.5 plus 4.5. Is it correct? Because 9 times 5 is 45. 45 divided by 10 is 4.5. And 4.5 plus 164.5 should give us 169. So our median is 169. Is it clear?
Yes.
Good. So that's the formula to find median in a group data. Finally, on that question is to find to calculate the mean, the mode, which also has some. Can I take it up?
Yes.
Good. Now, next thing is the mean, the mode. The mode has a formula is also L1. L1. Some may want to write anything they like, but the idea, everything must be defined. This is, that is delta 1. And that delta 1 means change. As if you are, that delta I wrote, some may write D1. As if you are differentiating. Differentiating means change. Changing. So delta 1, or okay, let me call this one delta 0. Call this one also delta 0. Call this one now delta 1. So we'll still multiply by C. Change at time 0. All over change at time 0 plus change at time 1. Some may even say is 1, 1, 2. So whichever one. What matters is that you are defining whatsoever formula you must have adopted. But the idea still remains constant. So, are you ready? L1.
Yeah.
L1 has been known. L1 is lower class bound. Settled. This one, change at time 0 is equal to differences between the modal frequency. Differences between the modal frequency and the pre-modal frequency. Difference between the modal frequency and the pre-modal frequency. If you check that question, we copy, or you copy. The class that has the highest frequency is what?
165 to 169.
Good. And what is the modal frequency?
1.
No, 10 now.
Okay, that's 4. 10 and 6, or we'll add the 5 and 6.
No. Mode is always one frequency. The class that has the highest frequency is 165 to 169.
Yes.
Then the modal frequency is 10, Nabi.
Yes.
The frequency before 10 is what?
6.
The frequency after 10 is what?
8.
So which means the first statement is pre-modal, which is 6. The second one will be post-modal, which will be 8. So this is now change at time 1. So that one is differences between the modal frequency and post-modal frequency. Differences between the modal frequency and the post-modal frequency. Is it clear?
Yes.
We already know C now as
5.
length of the year's class. So automatically, we can say that the modal class limit is 164 to 169. Is it 160? No, 165.
165.
Yes. 165. This is the modal class limit. And the modal class boundaries is 164.5 to 169.5. So our L1 is still 164.5. Our change will be 10 minus 6, 10 minus 6, 10 minus 8, and then class interval. So calculation will go towards mode L1 164.5 plus 10 minus 6. There is a pre-modal. Another 10 minus 6 pre-modal plus 10 minus 8. That's a post-modal. Then this is what? 5. So it's going to be 164.5. The upper one is 4, all over 4 plus 2 we'll have 5. So it's going to be 164.5 plus 20 over 8. The numerator is 4. 4 times 5 is 20, all over 8. Final answer will be 164.5 plus, if you divide this, I believe you will have something close to this. What do you have?
3.33. I mean 2.5.
Okay, everything is 3.33, Abby.
No, 2.5. 20 divided by 8 is 2.5.
Are you sure? Okay, 20. Sorry, I made a mistake.
20 divided by 6 is 3.33.
Better. So it will now be 167. 167.8. That's the final answer. That will be 6 because 4 plus 3 is 6, not times. So that is how to find mode, median, and mean of a group data. Before we draw it to a close, let's look at this. This one, you can use deviation approach to find mean. Deviation. You remember that? And that will lead us into measure of dispersion. But you can use deviation approach, or what we call assume mean approach, to calculate mean. That means you use an assume mean to get the actual mean. You know how to do that?
No, I do, but it's not fresh in my mind.
Because sometimes the question will say, using an assumed mean of so amount, calculate the mean, the actual mean. So that means you just, sometimes they didn't give you anything. You assume any of the thing. You will assume any value because it's called an assumed mean. You take an assumption from the variables, take a deviation, you will get the same mean that you would have gotten if you do not use an assumed mean. So let's see how to understand that. Are you set?
Yes.
Okay. Calculation of, that is forbidden. Calculation of actual mean using assume mean approach. Calculation of actual mean using an assume mean approach. This method is good if the number is so large. You begin to take what is it called, class center frequency. The stress could be that much. But with assuming it will reduce the number, and you can easily calculate depending on the question. So let's take question 1. We're going to look at when it is ordinary data, when it is that frequency distribution, and when it's a group data. We'll look at how it will be. And question 1, given 1, 2, 3, 4, 5, which we know before. 1, 2, 3, 4, 5. Find the mean. Given 1, 2, 3, 4, 5. Comma. Find the mean using assume mean approach. Using assume mean approach. You are aware that we have calculated that mean before. If I ask you now to calculate the mean of 1, 2, 3, 4, 5. If you add everything together, it should be 15, Abby. 1 plus 2 plus 3. Divide by 5, Abby.
Yes.
Answer will be 3. Normal calculation of mean. But using an assumed mean, you will still get the same 3. So The idea is this, which is called deviation. These are variables 1, 2, 3, 4, 5. It doesn't have frequency. So yeah, this is a deviation from assumed mean. Deviation from assumed mean. There are two types of deviation. Deviation from actual mean and deviation from assumed mean. Especially when we want to use it to calculate variance and the standard deviation that we did a little in finance, have we?
Yes.
But that one was a finance idea. But we applied the mathematical. So in this case, the question did not tell me to assume any. Sometimes they will insist on what you assume. So in this case, the variables are 1 to 5. You are expected to assume any of the numbers and you will get the same answer. If I decide to assume 4, I'll get the same answer. I assume 1, I assume 2, I assume 5, I'll get the same answer. But that one is advised in most cases to take the number at the middle. If you look at what's at the middle now, it's 3. But that does not mean if you take 2, you will have issue. But it's just that this number is very small. So I'm assuming 2. Are you following? I want to assume 2. If you go home and assume anyone, you would get the same answer. Except So our variable is 1. Our assuming is 2. 1 minus 2 is minus 1. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. 4 minus 2 is 2. 5 minus 2 is 3. The next thing is to add everything together the way it is there. By adding everything together, minus 1 plus 1 is gone. And the result here is what? 5.
5.
Without wasting much of our time, the actual mean is the assumed mean, which is A, plus summation of the deviation all over n. Assumed mean is 2. This one is 5. Total number is 5. And you are aware, 2 plus 1. Abu got 3 before, Abi?
Yes.
And it's the same. So you will like assume anyone. Assume 1, assume 3, assume 4, assume 5. Follow the formula, you'll get the same way answer. That is how to solve mean using an assuming approach in a single set of numbers. The next thing is to look at distribution. When it is in a distribution, and let's see how that works. You know, so when I got the D, it did remain. There was no frequency to multiply it. Now there will be frequency, there will be FT for us to run that. Can we take the second one?
Yes.
Okay. The second one, number 2 for this time. Second one will be, this is a variable. There is a question. 20, 25, 30, 35, 40, and then 45. So we have 3, we have 5, we have 1, we have 1, we have 2, 3. And the question says, find the mean using assuming approach. Find the mean using assuming approach. If you run this calculation yourself, as we have been doing, if you take time to say, add 60 plus 125, are you there?
60 plus 125.
60 plus 125 plus 30 plus 35 plus 30 plus 35 plus 80 plus 135. 35, 80 plus 135. What do you have?
Sorry, Mr. Bishop, where are you getting these numbers from?
I thought you know what I'm doing. You know that our normal process F times X, have you?
Yes.
So 20 times 3, 60, have you?
Yes.
Trying to just solve it without assuming. So 20 times 3 is, assuming this was objective question, you just say 20 times 3 plus 25 times 5, 30 times 5, 1, 35 times 1, 40 times 2, 45 times 3. So 60 plus 125. Are you there now?
Yes.
Plus 30.
Yes.
Plus 35. Plus 80. Plus 135. What do you have?
465.
465. Over 3 plus 5 plus 1 plus 1 plus 2 plus 3. That is frequency, Abby.
Yes, 15, 31.
So you can see that I've gotten the answer. If this is objective question, because you now say find me, you don't need to draw line now. A draw table, put X, F, S. No, your calculator can run it. 20 times 3 plus that, divided by the total frequency. You get your mean. And this automatically is our mean. But this question says we should not get mean straight. We should use assuming. So that assuming is what I want to use now. To still get the same 31. Can I do anyone?
Yes.
Good. Now we have here a table like this. This is our X. This is our frequency. So we have 20, 25, 30, 35, 40, 45. And this is our 20. Our 20 is 3. 25 is 5.
1,
This is
1,
1.
2, 3.
1, 1, 2, 3. So in this case, we assume what we like. Like I told you, when the number is very large, it's advisable you take the mid-two. But like I said, anyone you decide to take, 20, 25, 30, 35, 40, 45, you'll get the same answer. You can try it at two. Anyone you like, assume and redo it, you'll get the same. So the next thing is deviation. X minus A. This is our deviation. X minus A. So our variable, the first one is 20. Our A is 30. So 20 minus 30 is minus 10. 25 minus 30 is minus 5. 30 minus 30 is 0. And 35 minus 30 is 5. And 40 minus 30 40 minus 30 is 10. Then 45 minus 30 is what? 15. The one we did before, we just added this column alone. But because there is frequency in the question, we need to find FT. Because this is the deviation as deviation. So we then have 3 times minus 10 is minus 30. 5 minus 25. 0, 5, 20, 45. I hope you are with me.
Yes.
Are you still there?
Yes.
So there is minus 25 on top before that. And there is 5 and 20, 25. That's it. There is minus 30 and what is it called? Or a simple plus 20 plus 45. So what's minus 30 plus minus 25 plus 5 plus 20 plus 45. What's your result?
Mm. Hmm. 17 minus 13 minus 125. Am I adding
That's
it?
the answer. Add it now. Minus 30 plus minus 25 plus 5 plus 20 plus 45. What do you have?
Okay. 15. 15. Yeah, 15, 15.
1, 5, 16. Is it 1, 5 or 1, 6?
1, 5. 1, 5. Yes, I can hear you. I said it's 1, 5.
So the answer is not.
Hello?
Are you there?
Hello? Yes, I can hear you. It's like your network is bad.
Can you hear me?
Yes.
It just went and came back. Oh, have you copied that thing on the board?
Yes, it was 1, 5.
Okay, so 1, 5 over 1, 5. So that is the answer to that question.
But is that the answer? 1,
Any
5
other
over 1,
question?
5. Are we not using that? Are we not using
No,
that other
what I hope you
formula?
have not, you have not seen which other formula?
The assumed mean plus ED over N.
What we're talking about is the X bar now will be the assumed plus summation of that FG all over summation of F. Assuming 9 is 30 plus 15, which you just calculated over 50. Remember, we got at one that time, Abby? Hello? Are you there?
Yes. Hello? Hello?